Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. iit-jee. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the PYQ discussions on JEE Advanced Papers. Here I have got a problem from JEE Advanced Paper 1 2023. So let us read the problem and try to solve it. The question says a container has a base of 50 cm by 5 cm and height 50 cm as shown on the figure. You can see this. So here is the figure. You can see this is thickness or width, you can say, and this is the breadth and this is height. So this is kind of a rectangular parallelepiped. So here this face is having area 50 by 50 centimeter square and this is the thickness. So this is what it is said, and it is said again it has two parallel electrically conducting walls, each of area 50 centimeter by 50 centimeter. That means, you know, this shaded face, this face has area, you look, this has area 50 centimeter by 50 centimeter, and this area is actually conducting area, or this face is conducting. And similar to this, just opposite face will be conducting. The remaining walls like this one, so there are 4 more walls are there. You can see these two. So another 2 will be bottom one, and at right side another one. So there are 4 remaining walls. So the remaining walls of the container are thin and non-conducting. The container is being filled with a liquid of dielectric constant K at a uniform rate of 250 cm3 per second. So here is the point you have to note. The container is being filled with a liquid of dielectric constant 3. That means dielectric constant K is equal to 3, and it is filled with liquid at a rate of this, see, dV dt. This is actually rate of change of the volume of the liquid inside the container. Okay, this is 250 cm3 per second. Sorry, this is plus. So 250 cm3 per second is the rate of change of the volume of the liquid inside the container. Now the question is, what is the value of capacitance of the container after 10 seconds? Where you have been given the free space permittivity as 9 × 10⁻⁻12 coulomb square per Newton per meter square. And you have been told that the effects of non-conducting walls of the capacitance are negligible. Okay, so this is the question. You have to find out what is the capacitance of this container after 10 seconds. That means, you know, after 10 seconds the container will be filled with certain amount of liquid. Okay, certain volume of liquid. Let us find out what is the volume of the liquid. Okay, volume of the liquid after 10 seconds. After 10 seconds. So what you have to do? You have to just multiply 10 seconds with this just to get the volume. So it will 2500 cm3 This is the volume after 10 seconds. You have to find out the capacitance after 10 seconds only. Then what is happening here? So now the capacitor, you have these parallel phases. See, sum of the portion, suppose this much is filled with liquid and rest of the thing is filled with air. And you might be familiar with this kind of problem, that when you have parallel plates, conducting plates, and the space between the plate is filled with two dielectric materials of dielectric constant K1 and another one having dielectric constant K2. And say I'm just drawing just for the sake of distinction. Suppose they are just the gap between them is very, very small. Okay. Then what we have done. We have the area will be different for these two, A1 and A2. Right, the total area A will be the sum of this, isn't it? Now what we had done, see, if you have been given the terminals here, so these two will act as two parallel capacitors. Okay, so two parallel capacitors. So this is what we have learned. Okay, so here also see what is happening when we filled this container with certain amount of liquid, then the rest of the part will be having only air. So you have two capacitors. Okay, now in parallel combination, one is filled with, see, this is capacitance C2, suppose capacitance C2, this is capacitance, this is having capacitance C1. Okay, and this is filled with liquid. Okay, and this is filled with air. So this is the problem now. Okay, so therefore what you have to find out here, as I was saying, that the area for the capacitors here will not be the same. This will have area A1, say, this is having area A2. But how to find out the area, both of them? See, this is actually can be found out from here. If I know the area, see, this area is fixed, right? This area is going to be fixed, and this is the volume. So this is the thickness. So thickness is there, and this is the breadth. So what is the height? We can find out from here. So we know volume means, see, thickness D, and then length or breadth you can say, and height. Okay, so we know these two. Okay, then I can find out this one. See, H1 will be then H the height. Suppose this is the height which is filled with the liquid, then you will get this much area. Okay, so let us find out the height then. This height will be V by D into length L. So this is 2500 centimeter cube divided by thickness is 5 centimeter into this length is 50 centimeter. This will be in square unit. So you will get actually 10 centimeter. So we have got the height. Then what is the area of this? A2 will be actually, see, A2 will be the height into this. Okay, so that means you have 50 into 10 centimeter square. This is the area of this particular part, and the area of the air capacitor part will be 40 into 50 centimeter square. So these are the area. So once I get the area, now it is easy to find out the capacitance. So C1 is air capacitor. So epsilon 0 A1 by D. D is the thickness, that is 5 centimeter. I can just put it here. 9 into 10 to the power minus 12 into area is 40 into 50. I want to make into meter square. So 10 to the power minus 4 I have multiplied there. and here 5 into 10 to the power minus 2. Okay, this will give you the unit of farad. Okay, so you look, I can just do the simplification, and we'll get 36 picofarad as C1. Similarly, now C2 could be found out from epsilon 0, and there is a dielectric material having dielectric constant Ksa, and this A2 is the area, thickness is same. So epsilon naught, then K is 3 given, A2 is 10 into 50 into 10 to the power minus 4, and 5 into 10 to the power minus 2. So this will cancel. Okay, now upon simplification, what we get? 27 picofarad. So this is C2. So since these are in parallel combination, so equivalent capacitance will be C1 plus C2. Okay, that is 36 plus 27 picofarad, and all total you get 63 picofarad capacitance for the container after 10 seconds. And hope, yeah, so there are options here. You can see the second option will be the correct answer for this question. Thank you.
Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in iit-jee? India's leading online NEET coaching 100% success iit-jee. At TeenEinstein, we focus on iit-jee coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.